So I just found out my free video recording software now only has a 5-minute limit. Well, that's annoying. So let's talk fast about these three types of plate boundaries. There are some places where the plates are pulling apart from each other. They're moving away from each other. If you look at, say, the Nazca plate and the Pacific plate, this spot right here in the middle, they're moving away from each other pretty fast. There are some places where the plates are pushing against each other. For instance, you see how the North America plate is going up and around and like twisting down? Or the Eurasian plate is kind of forcing its way east? Well, in this spot right here, you see one plate going forward, the other plate going that way, and when they crash together, that's a different type of plate boundary. Now, the third type of plate boundary, there you don't see very many of these on this map because they're so common. A lot of times plates are just scraping past each other. They're not really going in different directions. They're not pushing together, they're not splitting apart. They're just kind of passing each other. Let's take a closer look at that. The three types of plate boundaries, this will be on the back of your page, are divergent, transform, and convergent. And these words just describe what direction it's moving. Start with the divergent boundaries. So first, how do they move? A divergent boundary is where plates are spreading apart. Now, this usually happens on the ocean floor. Most of our divergent boundaries are on the ocean floor. When they're under the ocean, they create two different kinds of landforms. A mid-ocean ridge, that happens when it's underwater, and the most famous one is under the Atlantic Ocean. Now, there's one place on Earth where two pieces of land, two continental crust pieces, are splitting apart, and that creates a rift valley. So, if you look at a picture of the world without water, you see right down here, down the middle of the Atlantic Ocean, is this weird looking landform that looks maybe like a scar or something. That's where the Atlantic Ocean, those two plates are splitting apart from each other and pushing away from each other. And every time that happens, a little bit of magma comes up to the surface, and then it freezes, and then it splits apart again. And that creates this ridge shape. Now, there's another mid-ocean ridge in like the Southeast Pacific, but the Mid-Atlantic ridge is one of the best examples. The other really great example is called the Great Rift Valley in Africa. It turns out that part of the African plate is moving a little more in one direction, and part is moving in a little of the other direction. So, in this spot, running down from Ethiopia through Kenya and Tanzania and the Congo and a lot of these areas, a valley started to open up. And as this valley started to open up, you start seeing a bunch of lakes forming. Eventually, scientists are wondering if the eastern part of Africa keeps going further and further east, but this part, the western part of Africa, doesn't, then they're thinking this might actually break off and form a new continent someday. That's what happened to Madagascar, and that's what happened to India, which is nowhere near this. This is what the Great Rift Valley kind of looks like from above. It just looks like a normal valley to me. But if you knew, you'd realize that this is the part where two pieces of the crust are pulling apart. That's a divergent boundary. The second type of boundary is called a transform boundary. Oh goodness, I'm getting a notification that I'm running out of time again. Looks like this video is going to be a three-parter. So get ready for transform boundaries in part 3.